All right, this week we're going to be looking at confidence intervals. Confidence intervals are an interval, as the name states, with a degree of confidence you feel the population parameter would fall. What's a population parameter? Like the population mean or a population proportion. Those are population parameters. We do this by collecting data, sample data, and then you will see later how the confidence interval falls within a sample minus some margin of error, and then the sample plus the margin of error. Now, they give you these critical values which are used to calculate the margin of error. I'm just somebody that I like to know how they find these values, and you can actually find them in Excel with this formula, the norm.s.inv, and if I pick my confidence as 0.95, I should get 1.960, and I don't. Let's even change it to 0.90. What's going on? This is where you have to understand the confidence is this value here in the middle. Remember, this is probability under this curve. This entire curve adds to 1. So if this is the middle, 0.9, how Excel, and the tables are red, is from the bottom of the curve up to these values. So if you want the positive critical value, which in the formula you will see you do, you actually have to take, so notice 0.90, there's 10% left over, right? So half gets cut off down here, half gets cut off up here. That's why in a 90% you are actually doing 0.95. That's how they're getting these values. Okay, so your confidence really is the 0.90, but you're having to look up the 0.95, and again, why? For this formula. Now, if you have this information, and sometimes you either manually have to calculate the margin of error. What's the margin of error? Plus or minus the sample mean. Within this interval is where we have confidence the population parameter, such as the population mean, would fall. Very nice and quick to be able to use this formula in Excel. So they want alpha. Remember, how do you get alpha? It's the standard or the confidence level minus 1. Okay, so alpha, in this case, this would be a confidence interval for 95%. I press enter, and this gives me my margin of error. Typically, within a table, you will see this given like confidence, and they'll give this value. Again, I could do this manually if I wanted to, okay, based off on this formula. And what I tend to try to do, so if I do a 95%, that's 1.96, the standard deviation. What I try to do is set up these formulas so I can see it's the critical value times the standard deviation over the square root of the sample size. So this is me manually computing the same answer. I set these up so now you can just change these values when you're working through these problems. So if you were given a sample of data and you want a lower and upper interval, right? An interval is you have a lower value to an upper value, and somewhere in the middle we have confidence that our population parameter, in this case our mean, would fall. Well, you can see by looking at this, I need X bar. Well, you know how to find the sample mean. You take the average of your data. In this case, in the Zybooks, they give you, because this is the population standard deviation, you can count the values that they're 9. And so to be able to find this, I just take, looking at this formula, X bar minus my critical value times sigma over the square root of my sample size. And I hit enter, and that gives me a lower bound. I can do the same thing of the upper bound. All it is just the plus now. Plus my critical value times sigma over the square root of my sample size. And you'll see that this will help you with the examples that you go through within the Zybooks. Another thing to note is, what if you want to know how many samples you should go out and get? In other words, a sample size formula. So let's say we want to do a sample size, we want to have confidence. Why'd I put 1.96? I'm going to do a 95% confidence, just my example. They give me sigma, and they give me the error. Okay, so all this information was given. Then all I have to do is compute this formula. I'm going to make sure the top, the numerator computes first, divided by the denominator, and everything squared. And then the rule is you always, always, always round up to one more. And in fact, you can even do that in Excel. You can do a round up. And I'm going to say no number of digits. So in other words, no decimals. And this allows me to round up. Again, I'm just, one of these big Excel users that I like to set everything up. So now I have everything set up. Notice on this left side, this is all when the population standard deviation is known. This side is when the population standard deviation is unknown and you actually have to find the sample standard deviation. So again, I can show you the same thing with critical values. So with critical values, I can use the equal t dot INV. This one's kind of nicer because it understands the confidence interval as two-tailed, so I don't have to do that adaptation where I had to add the bottom part. And then notice it wants my probability and the degrees of freedom. Do you remember what degrees of freedom are? They're the sample size minus 1. So if I hit enter, I get this first value that they show here. Same thing over here. Let's do an example in your zyBooks. They give me somewhere 0.05 for alpha, 0.216, and a sample size of 50. To find the margin of error, in this case, we're going to do a confidence T, alpha, comma, standard deviation, and then the, you already saw it right there. I see it right there, comma, the sample size. And so there's nothing different in this case as far as these values that are given. Okay, ooh, I did a norm and nobody screamed at me. I picked the wrong one. T, there we go. No wonder I got the same answer over here. Comma, there we go. Sorry about that. All right, so now you can see this was the confidence norm, this was the confidence T. There's more error over here because you do not know the population standard deviation. Okay, so you just have to be careful, whether to use a T or a Z. You have to use a T when the population standard deviation is unknown. Same thing down here. I can actually find, they did an example of a 99%, and they give me 2.797. The standard deviation, 0.217, and then 25, just an example in zyBooks. You might, in this case, since we have this information, okay, so the alpha 0.05 would be let's go up here, 0.05. What could I put for degrees of freedom? 24, right? So in other words, we could use and just see some of the similarities. That's what's kind of nice to do. Oops, let's do 49. I'm trying to match this one here and see if I do this manually, my critical value times my standard deviation over the square root of my sample size. And you can see that I did not update my t-value. There you go. So you can see you get the same answer whether you do it manually or you let Excel do it for you. Same thing down here if we have data. So there's not going to be a difference as far as when we have our data. Let's put my data over here. Your X bar is not going to change, right? So if I copied it right and I didn't, grab that there. Oh, I can see let's move you down. That's what happens when you don't have your glasses on, right? Okay, so get you back up there. So the X bar is not going to change. If we do not know the population standard deviation, then we actually have to compute the sample standard deviation, which again, you know how to do, right? So we have to compute this, and again, you can see it's a little different from the population. In this case, if I want to do a T, and this was the formula to find the critical value that I showed you. Notice the probability would be the 0.05 since it's 95%. And the degrees of freedom would be 8 because it's the sample size minus 1. And as you can see, you're getting a larger critical value. Okay, just to be complete, I can put that there. All right, so let's figure out the lower and the upper. Same thing, my X sample mean minus, my T times sample standard deviation over the square root of my sample size. I can do the same thing here, X bar plus T critical value times standard deviation divided by the square root of the sample size. So as you can see in this case, notice my interval got a little bit wider, and it's due to that error of not knowing the population standard deviation. Okay, so you just have to be careful with that. And then finally, the last thing, well, if you don't know the standard deviation, the population standard deviation, then you have to use the T. Okay, in this case, you have to use the T to be able to find your sample size. Now notice the 1.96 is a 0.95, but if I don't know my sample size, which I don't, I wouldn't know my critical value. Okay, so I am going to use the 1.972, which is actually given to you. Okay, in this case, they give you this critical value. They give you the sample standard deviation and then the margin of error. And so the same thing here, I can calculate my sample size. I always put the top in parentheses and then square. And again, if you want to use the formula, you can use the round up with no decimal places. So it's just kind of nice to have, I think, to have a spreadsheet set up where you can take data in. And what the spreadsheet's doing as well is it's helping you understand what all these pieces are. I mean, why do I need critical values? Well, I need it to find margin of error. Why do I need margin of error? Because there is going to be error in the population, okay, within the population parameter. This, once again, is saying we have 95% confidence that our population mean is going to fall within these boundaries. And that's important that you understand, you know, the critical value, how it is affecting your total margin of error, because, you know, if you're going to want to be more confident, you're going to see these values actually change. And that's actually, you know, probably something good to do. So notice this was 95% confidence. What if I change this to 90% confidence before I hit enter? Remember these values here. Notice our interval got smaller. Did you see that? So we started here at 95%, 90%, we have a smaller interval. Okay, so those are things you want to watch when thinking about, should you be more confident? What's going to happen with your margin of error?